Thank you very much, everyone. It's a pleasure to be here. And the title of my talk is The Future of Neuroscience Education from Active Learning to the Metaverse. A little bit of a different spin to the talks I've been listening to so far. Let's start from the talk of active learning. If we have to define active learning in one sentence, it is learning by doing. It is not a concept that is very recent. It has been around since the 90s, at least. And it represents a shift from knowledge retention to knowledge manipulation. And then maybe now you can start to see why it is relevant for AI as well. In 2021, with my friends and colleague Scott et al., we wrote this paper where basically we explain how active learning differs from the classic passive learning. You know, the one side on the left, you have the expert, on the right, the students. Passive learning in a lecture format, it is pretty much uninteractive, and there is limited space for self-reflection. It is very much knowledge focused, whereas with active learning, there is a lot of interaction going on. Not only it is interactive, but also collaborative, and it encourages self-reflection. It is focused on knowledge plus cognitive process. Probably you've already seen this pyramid. With active learning, we want to tap the very highest level of this pyramid. So not just remember, understand that are classic in the passive learning format, but more like the creation, the evaluation, the analysis, or the application of something. And of course, when we talk about active learning, we talk about learning by doing, and what can we do? With my friend and colleague Logan, I wrote this paper in 2020, a neuron paper, where we listed and discussed a series of tasks that actually occupy a large proportion of routine work in STEM, science, technology, engineering, medicine, but also, I will say, business and mathematics, but for which explicit training is rarely offered. Now, I don't have the time to go into the details for each of them, but think about plotting data in a figure, or writing an abstract, be it for a paper or a conference, or writing a travel grant. Well, these are all things we do routinely as scientists, but not very often we train students to do that in a very formal way. And then beyond academia, this can apply also to industry, so startups. Think about verifying data integrity or storing data or preparing and presenting a work, be it poster or a slide deck, within a limited amount of time. These are all active learning tasks. Probably are more familiar with finalizing a report, but also it is something that it has incrementally more importance in many charities, for example, or grant writing tasks, public engagement activities. So even asking our colleagues to conduct, or the student to do a public engagement activity, can be considered an active learning task. But then there is more, because active learning tasks offer flexibility. On the one side, we just need a device with an internet connection supporting two-way video calling. And on the other side, with my talk, with my webinar, I'm not saying that we need to forget completely about the classic passive format. It is not an irony that right now I'm not using active learning to teach you or to share with you what I know. But actually, every lecturer or every person can find their own preferred way of sharing knowledge. But at the same time, if you are, for example, within an academic setting and you want to implement active learning, these are 10 steps you can follow. Number one, identifying curricular needs and see where, for example, you can integrate active learning, and see if some of these tasks are already available or online, for example, or if you need to create your own. You integrate the task, but then you also need to evaluate how things are doing. Once you do that, you cannot forget about support for staff and train colleagues, and develop a digital infrastructure that in the medium term will help you sustain these in-person and online active learning. Of course, as for many teaching materials, we need to update them over time. Ideally, we can share best practices and resources and make them accessible globally. And then I'm a big fan, as a neuroscientist, educator of neuroscience educational research. I think we need to do in the medium long term educational research to see how what we've done has been integrated, has been received, and what we can change. Step number 10, as final one, we need to leverage new technologies and new platform. And then we can repeat the cycle again with different topics, for example, or different tasks. So far, I've listed an example of active learning tasks that can be done with very minimal technological support, or pretty much even with no tools at all, apart from the device with the two-way video calling. But imagine what we can do with augmented reality or virtual reality. A couple of years ago, I wrote a paper on that. So given that today I only have a 20-minute slots, I will not go into much details, but if you're interested on this topic, this is the paper. Neurology, written by me and Chad Carson. Another of my preferred area of research is how in the future, many of the things we do now in person or online can be done within the metaverse. And my special interest is neuroscience and neurology education. Now, I don't know how familiar you are with this concept, but I wrote this Nature Medicine paper in 2022, where I wrote how I think medical education will massively benefit from moving or actually accompanying the real world with the metaverse world. What is the metaverse? For the sake of this webinar, we can define it as an immersive and creative virtual environment characterized by elements of augmented, virtual, or mixed reality. It is populated by avatars who are graphical representations of users. And they can be personalized and they have humanoid or non-humanoid features. I think that in the future, many educational endeavors can also take place within this space. How? Very simple, theoretically. We can have a device connected to Wi-Fi, a device or a computer, a mobile phone, a laptop. We will be required to select an avatar. In this case, I will stick to humanoid feature because there will be also sort of metiquette, the metaverse etiquette. We can personalize the avatar, select an environment, select a teaching activity. I'm also a big fan of game-based learning, gamification approach. And then invite avatars, other people to work with us or to share an educational session with us. Now, of course, we don't just do it within the metaverse for the sake of doing it there. But I think that especially in many areas of neuroscience, neurology, but also other health professions, there can be a truly added value in, for example, exploring the anatomical structures with a close look in a 3D or even a 4D reality, where you can interact with the neurons, for example, or with the different parts of the brain. And then again, we can increase the engagement of the learners, because pretty much we all like playing games. And at the moment, more than 3 billion people worldwide play video games, many of whom are already playing in the metaverse. And this is like the perfect ideal audience for educational training. I mean, think about the people who are now 16, 18, 20-year-old. Many of them use already many metaverse platforms. So I think we need to meet in the middle, not just lecture format in a passive way, but also some active learning in the metaverse. As I was anticipating before, this is the paper if you want to delve deeper into gamification and game-based approach in neurology and neuroscience. You can find a critical analysis, the applications, challenges, and opportunities. The journal is called Brain Disorders. But then, of course, there is a golden side, but also potential problems. According to a recent UNICEF report, for example, 759 million people between 15 and 21 do not have an internet connection at all, which is, of course, a major limitation, something that can only increase the digital divide. And also AR or VR visors or glasses, which can be instrumental for a truly immersive experience, not only come with a sort of financial cost, however little or big it can be, but they can also cause side effects, like eye discomfort, strain, fading, and blurred vision. And also from a sustainability perspective, scalability perspective, the overall carbon footprint of the metaverse is still unclear. All these will become topic of discussions for the next year. But now I also want you to be critical towards this active learning concept, because there are some limitations too. And in the final minutes, I will provide also a couple of suggestions on how we can overcome them. For example, if you ask your students to do an active learning task instead of following the classic passive lectures, they might feel inexperienced with the new formats. And also, and this is something that many people reported in the literature, including Deslosier colleagues in 2018, there is an increased cognitive challenges they experience within this cognitively demanding environment, opposed to the so-called cognitive fluency of the lecture. Long story short, students worldwide are way more used to having to sit down in a lecture theater or in front of their computer and listening to someone lecturing them. Whereas learning by doing, of course, it requires more energy. Can we say that? They're not experienced, they don't really feel they're learning, but we need to manage their expectations. We need to share with them why we do that, explaining the relevance of the approach we use. And then what I found very helpful so far is the contextualization of the activities from a career perspective. Let's think about scientists. If they want to become a scientist, chances are that they will have to learn how to write a grant, an abstract, store data, write a poster or prepare a slide deck within a really short notice. So we need to contextualize them, tap into the motivation and engagement, and maybe, I didn't write it, but add a little bit of a gamification element to it. Of course, there are benefits of active learning. I will only mention 7 now. Point number 1, active learning increases students' performance in STEM across all course types, all course levels, and irrelevant from the class size, but especially beneficial in small classes. Active learning also shown benefits and non-inferiority, if not superiority, across educational levels, from undergraduate to postgraduate, and across disciplines, from astronomy to neurology, from psychiatry to zoology, and I've written a couple of papers on that. Active learning, and this is benefits number 3, narrows the achievement gaps for underrepresented students and can promote equity in education. This is a bit taken from Theobald and colleagues and Ballen and colleagues. Active learning has a disproportionately beneficial impact for individuals from low-income backgrounds and students from underrepresented minorities. But there is more than that. Active learning engages students and maximizes their learning within an online environment, and increases student satisfaction, not only in individual session, but also within group learning session. And yes, you need technology, but not for active learning, because in this study from 2017, no significant differences in grades for the same course in a high technology-based active learning classroom environment versus a low technology-based one were found. And then last but not least, I'm a big fan of education. I'm an educator, I'm a scholar. All this active learning contributes to a stronger community via increased sense of belonging and by promoting community of practice characteristics such as becoming, which was first identified and studied by Wenger in 1999. So I only had 20 minutes, but I hope I gave you some directions and key references about how we can integrate active learning, share our passion with the next generations, and possibly be prepared for the metaverse revolution that probably will arrive sooner or later. Thank you very much for your attention.